Hi, I'm Jennifer Durso, Project Muse's production manager. In this Muse brief, Angie Ormiston, who is Project Muse's Director of Publishing Technology, and I are going to talk about the results, features, products, and workflows that are possible when AI technology is applied on a platform such as ours. We will also discuss the ways in which Muse has already begun to harness the power of AI to offer exciting new features for our users, and how we plan to expand our use of AI technology to all parts of our platform in order to continue to improve our offerings for all of our various customers.
There is no doubt that artificial intelligence, natural language processing, text analytics, and machine learning will all be an integral part of whatever the future brings for the scholarly publishing ecosystem. And Muse knows this all too well, and all of us at Muse are excited to be a part of it. One way that Muse has already embraced this technology is by unveiling our enhanced related content feature that offers users suggestions of content related to each document. We have offered a similar feature in the past based on technology that was not available to us at this time. However, we were never entirely satisfied with the results. At times, results were not quite as broad as we would have liked. There was also an issue that relationship mappings for our recent content would not be available to users for an extended period after the launch. Rebuilding this feature with AI technology has improved the results dramatically. If you have not seen these yet, you can find related content suggestions on the content pages. You can just click on that icon. Muse has suggestions at the chapter and article level. We are working to add this to the book and issue levels. Yes, we are still working on that UX for a displaying of these suggestions, but so far we are very happy with the suggestions themselves. We are especially pleased because of our analytics. They are showing an uptick in users using this feature, and these relationships now exist across subject areas, publishers, and content types. The relationships are defined by concepts that are found throughout each entire work instead of just by the presence of a particular word.
I'm especially excited about the ways that we can use the same results that power our related suggestion content on other parts of the site. For example, we have seen an uptick in discovery that we think is because of our related content suggestions. Could we drive a similar uptick in sales to individuals if we place these types of suggestions on the pages where individual users purchase content? We intend to find out. Basically, what we're going to do is say to customers, since you bought article XYZ, we think that you would be interested in book ABC and article DEF. It's a feature that we're all used to seeing on all sorts of e-commerce sites these days, and we're excited to bring it to Muse. So, how is Project Muse able to do this? How are we applying AI technology to create related content suggestions? The answer is simple. We have a very smart tech team, and we chose a very good partner. Project Muse has partnered with Unsilo. By using their recommendation engine, data has shown a significant improvement in the output of results. Unsilo allows Muse book and journal content from all of our publishers to be indexed alongside big data. By using big data corpus analysis to understand semantic similarities, we will have the ability to use concepts that require no taxonomies and no ontologies. Through automation, speed and quantity are no longer an issue when creating related results.
Before 2012, when Muse had just journals, Muse categorized content based on the Library of Congress subject headings, which cataloging librarians assigned to each article in Muse. The advantages were that we have granular data sets based on a well-known taxonomy that was familiar to both our library customers and our end users. We could use this data set to make connections among our content. This was all great, but it did come with substantial disadvantages as well. It was very labor intensive, time consuming, and expensive. As time progressed, we also became aware of limitations. The subject headings were slow to change and adapt to the ways that people use language. We were particularly concerned with the use of the words that had come to be understood as derogatory and offensive to our certain marginalized groups. This was incompatible with Project MUSE's commitment to promoting equity, justice, and inclusion. Muse searched hard to find another path, another standard. However, we consistently ran into similar issues. Even the taxonomies that were specifically designed to be focused on inclusivity did not quite meet our needs. For example, they continued to use words that had evolved in meaning, or they did not include options that fully covered our wide-ranging social science and humanities content. Finding a set that incorporated slang seemed almost impossible. We thought about making our own taxonomy. We thought about joining others. We even thought about joining ours and others, but that we decided was a high upkeep and it appeared to present the same issues. Language changes fast. Even yearly updates within any taxonomy seems to have a hard time to keep up. We know that we wanted to do better and we knew that we needed to. After experimenting with different classification systems, we decided that AI is going to be the way that we need to move forward into a world beyond taxonomies, a world where language evolves and so does the technology that's around it. Unsilo's technology extracts concepts from each piece of content. A document can have over 250 concepts extracted. Those concepts are weighted and easily mapped. The ability to define concepts at this granularity has the possibility to reduce the container's current constraints in discovery. It can change the current biases, and it can reduce the misconnections by the limited classifications. This is a solution that uses a semantic understanding of academic content to support the discovery of existing and new research. Muse has begun looking into transforming our platform using AI. Starting with the feature small like related content, we plan to continue to evaluate all of the features on our front end. We also plan to look at our metadata systems, our sales practices, and the overhaul of the production system. But most excitingly for me is the Muse Search. Muse is ready to innovate our search once again, and we have finally begun these conversations. The culmination of linked data and AI will allow the creation of semantic links without manual workflows to create them. This will offer a search experience that can provide information connected to content before the content has ever even been read by the user. Please let me explain with an example of a search looking for the term yo-yo ma. When using a broad search like this, users may be used to seeing results ordered by relevance, with some weight derived from the number of occurrences that yo-yo ma was found in that full text. Instead, I would love to see more information surrounding concepts about yo-yo ma. A user can be informed that he is a musician and be presented with results that not only tell you his birthplace is Paris, France, but presents information about the region without having to start a new search. The search can list the works that he played and perhaps a few that he even composed. While connecting each of those listings to when he played them, we can also then layer in recordings. Of course, this data is linked to allow spidering further down into any one of those information pathways and many others that I'm unaware of. It is all linked data. But of course, this particular data set I would expect comes from the data that has been indexed and learned, not layered in through human-defined metadata outside of this content. You know, in my opinion, let the computer do the work. The computer has done all the research for you, so let them show you. My colleagues and I have just begun envisioning what's next on this search. And though these things are just beginning conversations, I hope that you'll be able to join in on them. And if you are interested, you can remind me another day. I would love to be able to talk to you about all of the awesome ways that this amazing data can be displayed. While I am here talking about ideas and my hopes for embracing AI and where AI can help take our scholarly research, let me just give you one more example of just how different research and search can be. Let's say that a researcher types the word cloud into an old style search engine that just relies on the full text and the keywords. The results would include everything from articles about meteorology and computer science. The search engine does not know the difference between a storm cloud and the cloud, that thing where all the information seems to be stored these days. By ingesting and indexing huge amounts of content from different sources, different fields, and even different time periods, a computer can learn that there are multiple meanings when referencing the word cloud. But that is not where it can end. Muse is striving to go further. We do not just want a great search engine. We want to create a great search experience based on that powerful search engine.
Let's keep considering the cloud example. There are all sorts of ways that a user can indicate what type of cloud they're interested in. For example, if they want content about the cloud, they could just search in a database related to scholarship about technology. In a more general system, they could use additional modifying terms or a facet. These methods work, but not necessarily as well or as seamlessly as a search based on AI. With AI, someone can look up the word cloud and see that there are multiple meanings and then follow the direction that they want to go.
That is great, Jennifer, but I'd like to go just a little further. We all know that Muse offers our customers features like save history and save searches. And yes, the AI environment should improve those functions when we get there. But why not add even more data from features like recently viewed into that search? Taking the user's data has the opportunity to educate the search, allowing the users to arrive at the intended result. Another option, how about we let the user upload a syllabus from their professor? If that search can find the citations and the content it had indexed, then our search results can provide related content, or at least define the specific categories. And now it can deliver details along with the results to content. Would that not be a great user experience to offer to end users, researchers, and professors alike?
Oh, it certainly would be. I wish that had been available when I was in school. I can't imagine how much time and agita it would have saved me. This technology is a complete game changer. The connections, the relationships that it can draw between the content that a user has looked at and other content that the user might find interesting or helpful is really stunning. Now, related content suggestions, search, and categorizing content are some of the big splashy ways that Project Muse has already brought or will bring the power of artificial intelligence to enhance our platform. However, there are smaller, less visible, but equally impactful ways that we can use AI. One way that has been discussed is to make our popular Muse and Focus feature even better. For those of you who might not be familiar with Muse and Focus, it's a feature that allows us to present curated collections of book and journal content on different significant topics. Past Muse and Focuses have dealt with climate change, gun violence, and the global attack on democracy, among other important subjects. Our original way of creating a Muse and Focus piece involved seasoned researchers spending a significant amount of time using our current tools to generate a list of potentially relevant books and articles. They would then peruse each piece to make sure that it addressed the topic in a way that fit in well with the other work selected. This method resulted in good, solid Muse and Focus features, but it was time-consuming and labor-intensive. We also could not guarantee that we had captured all relevant content on our site. The last thing that we wanted to do was leave out someone's work because of the manual process. We realized that the same AI technology that supports our related content feature and that will one day undergird our search engine could also be engaged to make the process of creating a Muse and Focus more efficient without sacrificing the quality that our customers have come to expect. This same technology will also give us the option of making our Muse and Focus collections living documents that could be continuously and automatically updated as new relevant content is added to our site. These same basic principles are the foundation for our newest experiment for creating custom book collections for our institutional customers. For our new book sales model, known as Book Custom Collections, we had originally planned to rely entirely on the BISAC and BIC classifications provided by the publishers in the book's metadata. We would then map the BISAC and BIC codes to the Muse sales categories. This method worked, but there was a large learning curve because BISAC and BIC are not necessarily meant to be used this way. We also discovered that not all BISACs and BICs mapped seamlessly to our sales categories, and that sometimes publishers submitted good, high-quality books that we wanted to include in our corpus, but that didn't fit neatly into our categories. Sure, we could solve this problem by forcing the content into the closest category, but we were not convinced that this was the best solution for either our sales team or our customers. Instead, we chose to augment the BISAC-BIC mapping with AI technology. This gives our sales team the flexibility to use the tools and methods that best meet the needs of the customer that they're working with. And Muse is all about meeting the needs of our customers. Now I want to shift gears and talk to you about what I personally am most excited about. And that's how we are planning to apply AI to our production systems. We are in the process of completely revamping and modernizing our production system. And a big piece of that is exploring ways to integrate AI technology to improve quality control and efficiency, while also offering important new services to our publisher partners. These services could include a wide range of features, such as automated reporting and predictive analytics. What if content translation and/or moderation could also be done on the Muse platform? What if Muse could use AI to generate high-quality abstracts, perhaps even in a variety of world languages, for content that does not have them? Imagine what that would do for discovery. AI can build features and can improve workflows. AI can reduce day-to-day repetition and decrease costs. AI can change our understanding of how one conducts research.
Jennifer and I want to thank you for watching the Muse Brief and encourage you to join us at the Technology and Humanities networking session during the live portion of the Muse Meets on Wednesday, April 6th at 2:15 Eastern Time.
Thank you.